Good morning, science fans. I hope you're all ready for another episode of Science TV with Mr. C. I am your host, Mr. C. Pitter patter, let's get at her. So for today, several assignments from last week due today. So make sure you get those submitted and shared if necessary. This week will be very similar to last week in that everything is now available for you to get done today. If you want to cram it all in one day, do it. If you want to wait till the last minute, that's fine too. Choice is yours. Choose wisely. Today, in class, we're going to kind of refer back to last week. Last week we were doing molecular compounds or covalent bonds. There's a naming system for them we're going to practice today. That naming system looks like this. This is what you're going to do. You're going to submit your answers in a text box available for you, and the link should be up here for the text. So, to name a molecular bond, first thing you do is you start with the element's name. For the first element, you start with its element's name. So, for instance, water, H2O. We would start with the element's name, hydrogen. For the second name, you start with the IDE name, so hydrogen oxide. Then we're going to use prefixes to show how many atoms of each type there are. Do not use mono if the first element only has one. If your combination has, where you write your answer, there's letter AO or OO, simply drop the A or the first O and have an O. And you'll see that as you go through here. So for H2O, water, it would actually be called dihydrogen monoxide. Remember, we don't use mono in the first element, but the second one we do. Monoxide, M-O-N-O, and if you had oxide at the end, it would be two O's, so we would drop one of two O's and leave it with O-X-I-D-E. Another example, right here, dichlorine heptoxide. We have two chlorine, so the Di, chlorine, and 7, we use our scale down here, hepta oxide. Well, hepta would be AO. Again, our rule is to drop the O. So we have the rules here we need to follow to name these compounds. You are going to take these 13 formulas and rewrite them using this naming system. The first one, nitrogen, fluorine. So for our naming this one, we're going to write the first element, nitrogen. There is no prefix to it, so it stays the same. Fluorine, we're going to use the ide name, so it'll be fluoride. Since there are 3, we try. So nitrogen, trifluoride. Do the next 12 in a similar manner. Next, we have oil spills. You should have learned very briefly about how there are polar bonds. We can use those properties of the polar bonds to help us. This talks about some oil that's being spilled, how we can use the properties of polar bonds to help clean it up. Soap has it helps break those bonds and rearrange things. If you've ever seen like detergent in a greasy pot, and you put it in there, and the grease kind of just dissipates away from it. We can use that. That's polar bonds. So it's all chemistry that causes that to happen. So you're going to read 2 different ways to clean up oil spills, and you're going to answer a couple of questions about it. Again, text box entry. So you go up here, type in your 3 answers, click submit, done. Next, we're going to review some slides. 37 to 47. This is truly just review. We've talked about a lot of this already, but we're going to talk about it again because that's what we do here. We talk about science. Sometimes we repeat ourselves. So chemical reactions, how can we tell they've happened? How can changes in matter be described? Well, we're going to use properties. And what's another term for property? It's a characteristic or a trait. Okay? We know there's physical properties and chemical properties. Some physical properties would be something that you could observe with your senses. You could see it, you could smell it, you could taste it, you could hear it. And chemical properties are things like the ability to rust or burn or change color. Now, you've probably seen images of the Statue of Liberty. You've probably seen old paintings that have a different color to them. That is reaction between copper and substances in the air like oxygen and nitrogen. The copper is reacting to it. The actual Statue of Liberty is made of bronze, of copper, and it should be a bronze color. The Statue of Liberty, when we first received it, looked like a shiny new penny. But it's been reacting over the last 37 years? We haven't had that long, but for the entire time we've had it, it's been reacting. So this is what it would have looked like back in 1886. Here's what it looks like today. New pennies look like this, and over time they react chemically. So not only do they have physical change, they have chemical changes as well. So again, physical, observable by senses. Chemical, the ability to change in other substances, rusting, burning, and chemical dissolving. A little more reinforcement there. So physical changes, they still more or less are the same thing. Chemical changes, they are a new substance. A couple of videos here if you want to see a slow motion chemical change. A match being stricken, going from blue. It strikes, you can see the sulfur come through it and all the chemical boiling actually are there. It's kind of a cool little video. If you have time to watch it, I recommend it. I thought it was cool. And there's some really cool slow motion videos here that I kind of went down a rabbit hole and just added to it. So chemical changes happen when existing bonds break. You get new substances. It becomes something else. A little joke for you. And there's some ways you can tell a chemical reaction has happened. It changes colors, or it changes state. It goes from a solid to a liquid, or a liquid to a gas. The temperature changes it in it, or the pressure. If we had an enclosed container, and the pressure changes because of the result of mixing two chemicals together. Maybe it gets higher pressure because the two things are expanding, or a lower pressure when the two things are contracting. Or if you smell an odor, it usually means that some chemical change has happened. Of course, we have the changes in energy. Exothermic is releasing heat, and endothermic is absorbing heat. Absorbing. There we go. Reactants are the things that are being changed. The products are the result of that change. And that is all we need to know for these slides. Again, look over them, kind of get comfortable with them. It's a pretty much review for the most part there for us. Now we get to the difficult part. Balancing equations on the calendar here. It is asking you to read this, follow these directions, kind of brings you to a website that looks like this. You're going to use that website to do a couple of things to help you learn about balancing equations. Here's the workspace you can look at. We're actually going to follow this link here that I've done some adjusting to help you with this. It looks like this. You know what? Let's bring this up. Make a copy. Make sure you submit or share and submit a link to it. Hopefully I've got this set up for you. I do. All right, cool. All right, so we have these links here, this website. We're going to balance these equations. And remember, the law of conservation of matter. You cannot create or destroy matter. That becomes very important when balancing these equations. What goes in, what comes from these two reactants must come out for the product. Now, we can change the amount of atoms here by using a coefficient. We cannot change the ratio here, the subscript. These have to stay the same, the second number. But what we can do is change the first. So this website here is a nice tool. If you put a 1 in front of it, it shows you that if there's one molecule of H2, you have 1, 2 hydrogen. If you put a 1 in front of this, you have 1, 2 chlorine. So it's one atom, or I'm sorry, one molecule of this means we have 2 chlorine. On the other side, if we put a 1 in front of it, we show that there's only 1 hydrogen, 1 chlorine. That's not correct. Both sides of the equation have to equal each other. To do this, we can change the coefficients. So if there are 2 of these molecules, that means we have 1, 2 hydrogen, which matches over here, and we have 2 Cls, which matches over here. This is a balanced equation. H2 plus Cl2, this means yields, or equals 2 hydrochloric acid molecules. Okay? On this, what I have changed to, I've put little formulas in here to help along with this. Okay? So we start with H2 plus Cl2 yields HCl. We are going to leave this top part alone. It's going to fill in by itself as we go. So the balanced equation, we start with a 1 here. Punch it in. It automatically tells you how many atoms are in the reactant. Go to here. Put a 1. Shows us how many are there. Now we want this number to equal this number. Both of them have to equal for it to be balanced. Okay? So we have 2 hydrogen. We want to get to 2 hydrogen. So to get this 2 hydrogen there, we're going to start with the coefficient of 2. We'll see what that does, see if we do anything else. We put a 2 there, it shows we have 2 hydrogen, 2 chlorine, these numbers match. We're good. This is a balanced equation. Now when you were to write this, you wouldn't write the 1s. The 1s are understood, so you wouldn't do anything about that. So the balanced equation should be H2 plus Cl2 yields 2 HCl. Okay? We'll do one more together. Down at the bottom, number 5 is probably the most difficult one. The worksheet you guys had to do kind of was difficult for you here as well. Alright, so here's our equation. We start off with aluminum plus oxygen equals dialuminum oxide, or trioxide. So aluminum. We're going to start with a 1 here, start with 1 here, and see what we've got. So we have 1 aluminum, and we have 1 here. We have 1 in all 3 of them. 1 aluminum, 2 in the product. 2 oxygen, 3 in the product. That makes things complicated. Let's do the easiest one first. How can we get 2 aluminum? Well, on this side, we could make this 2. That matches up. We're not done yet. We still see oxygen is misbalanced. Easiest way to do it, since you can't take away them, we have to add them. So we're going to start with a 2 in this box to see what that does. Now we have 4 oxygen, 3 in the product. That doesn't work for us. So we have to add some more. Since we can only go up a number, we have to put a 2 out in front of this. Now we have 6. Well, that's a problem. 4 to 6, 2 to 4. So we're going to come back over to this first part. Let's work with the easiest number first, I suppose. We could change the amount of aluminum. 4. That works. And instead of 2, let's try 3. That works. So this equation would be 4Al plus 3O2 yields 2 Al2O3. So we've got to get these numbers in the reactant equal to those in the product. We're going to get lots of practice with that. So let's just Try to get through these 5 here, share, submit, and we'll go from there. If there are any questions, Chatterdoc is available, as is email. Thanks for watching today, and may the 4th be with you.